When most of us look up in the sky at night, one of the biggest questions that we have is, are we alone? Or if not that question, how did we get here? In our solar system, there are only 2 atmospheres that are made mostly of molecular nitrogen. And one of those is our own atmosphere. The other one is Titan, which is the largest moon of Saturn.
And because of that atmosphere, it has a lot of Earth-like processes that you and I are very familiar with, like rain, rivers, sand dunes. And yet, the surface temperature on Titan is 200 degrees Fahrenheit colder than the coldest place here on the Earth. And so you might expect that means the chemistry is going to be a little bit different, and it is. And it's that chemistry combined with the Earth-like processes that make Titan such a fantastic destination. Dragonfly will launch in July of 2028 and will arrive on Titan in early 2034. Dragonfly is a nuclear-powered drone. It's about the size of a car, which sounds really big, but we're trying to carry a lot of scientific instrumentation with us. As the deputy project scientist, I work to make sure that the hardware that we're building, the systems that we're building, are what we need to actually do the science on the surface of Titan, applying that expertise in autonomous navigation, but to a totally new and foreign environment. The mass spectrometer is the premier instrument on Dragonfly. It's in the head, if you will.
And what mass spectrometry does is it just does a very, very precise measurement of the mass of a molecule.
On Titan, we're going to tens of different locations, trying to sample a variety of surface compositions to get a really good understanding of what Titan is made out of.
One of the things that my lab does is we actually run simulation experiments of Titan's atmosphere. And when we do that, we produce these same organic molecules that we think are present both in Titan's atmosphere and also on its surface. We can do things like test instruments, test our data analysis techniques, also think about our understanding of what we might encounter when we get to the surface. For example, the other main gas in Titan's atmosphere is methane. Methane and nitrogen interact with light from the sun. It breaks those 2 molecules apart and makes small pieces. Those pieces react with each other to build larger and larger molecules. And most of those molecules are what we call organic, so there's carbon in them. And those are the kinds of molecules that we think about being important for the origin of life.
So I would be shocked if we didn't find something like amino acids. How far does that chemistry progress? And then things that we learn about Titan's climate are important for understanding our own climate here on the Earth.
That's particularly important as our planet is changing because we're getting out of the phase space that we have been used to, and so we're going to have a lot of questions about how Earth's atmosphere will respond going forward. And we're going to see things that we've never seen before. We're going to learn things that we have been trying to figure out literally for decades, like questions that I have been trying to answer for decades. Like, we're going to get the actual real answer, and I can't wait.